October 4th, 1942. Federal Shipbuilding and Dry Dock Company, Kearney, New Jersey. The keel of USS Nicholas, hull number DD-449, was laid on a massive construction way overlooking Newark Bay. Welders sparked blue-white arcs as they fused steel plates together. Riveters hammered. Cranes swung structural beams into position. Foremen shouted orders over the industrial din. It looked like organized chaos, hundreds of workers swarming over a skeleton of steel that barely resembled a ship. 4 months later, on February 4, 1943, USS Nicholas slid down the ways into the water, fully constructed, ready for fitting out. 39 days after that, on March 15th, the ship was commissioned into the United States Navy. Total time from keel laying to operational warship, 162 days. In that same time period, roughly 5 months, Japanese shipyards had barely completed the hull of a comparable destroyer. Japanese construction methods, still relying on techniques perfected in the 1920s, required 24 months to build a destroyer from keel to commission. American yards were building them in 6 months or less. This disparity, American destroyers constructed in 1/4 the time required by Japan, represented one of the most decisive industrial advantages of World War II. It was an advantage born not from superior ship design or better materials, but from something more fundamental: the wholesale application of American mass production techniques to warship construction. The Japanese built ships the way craftsmen build custom furniture, carefully, precisely, one at a time. The Americans built ships the way Henry Ford built automobiles, on assembly lines with standardized parts, using techniques that valued speed and volume over individual perfection. That difference would help decide the outcome of the war in the Pacific. When Japan attacked Pearl Harbor on December 7, 1941, the United States Navy possessed 171 destroyers. Many were old, dating from World War I. Most were scattered across the Atlantic and Pacific. The Navy's war plans called for simultaneous operations in 2 oceans against 2 major naval powers, Japan and Germany, plus their allies. Planners calculated they would need at least 400 modern destroyers to meet these demands. Destroyers were essential to naval warfare. These relatively small warships, roughly 2,000 to 2,500 tons displacement, 370 feet long, armed with guns and torpedoes, served multiple critical roles. They screened aircraft carriers and battleships against submarine and air attack. They hunted enemy submarines. They escorted convoys across the Atlantic and Pacific. They conducted shore bombardment, rescued downed pilots, and fought surface engagements against enemy vessels. Without adequate destroyer strength, the Navy could not protect its capital ships, could not secure the sea lanes needed to project power across the Pacific, and could not support the amphibious operations necessary to defeat Japan. The challenge facing American shipbuilders in December 1941 was stark. Build hundreds of modern destroyers, build them quickly, and build them well enough to survive combat against a determined enemy. And do it while simultaneously building aircraft carriers, battleships, cruisers, submarines, cargo ships, landing craft, and every other vessel the Navy required. Rear Admiral Edward L. Cochrane, Chief of the Bureau of Ships, captured the urgency in a January 1942 memo to shipyard executives. We need destroyers immediately, not in 2 years, not in 18 months, now. Every month of delay means more merchant ships sunk by U-boats, more carriers operating without adequate screens, more soldiers and Marines without naval gunfire support. Speed of construction is as important as quality. A destroyer delivered in 6 months is worth more than a perfect destroyer delivered in 2 years. The Navy's answer was the Fletcher-class destroyer, a design optimized not for individual superiority, but for mass production. The Fletcher-class, designated DD-445 through DD-804, incorporated lessons from earlier destroyer designs while emphasizing features that simplified construction. The hull used simple, straight lines wherever possible. Curved sections were minimized. The ship's structure employed repetitive frames and standardized compartments. Almost everything, engines, generators, pumps, valves, electrical systems, was standardized across the entire class. This standardization served multiple purposes. First, it allowed different shipyards to build identical ships from the same plans. A destroyer started in San Francisco could use components manufactured in New Jersey. Second, it simplified logistics. Spare parts for one Fletcher-class destroyer fit every other Fletcher-class destroyer. Third, and most critically for construction speed, it allowed shipyards to prefabricate major assemblies and install them as complete units. Commander Joseph Taussig, who served as Bureau of Ships liaison to multiple shipyards, explained the philosophy in a 1943 report. "We are not building custom warships. We are manufacturing destroyers using industrial production methods. The Fletcher-class is designed to be built in sections, assembled on the ways, and completed rapidly. We have sacrificed certain optimizations, slightly better hydrodynamics, fractionally improved armor placement, in favor of construction speed. The result is a ship that is good enough in every respect and can be built in massive numbers quickly." The numbers prove the concept. Between 1942 and 1945, 19 different shipyards produced 175 Fletcher-class destroyers. These ships formed the backbone of the Pacific Fleet's destroyer force, participating in every major naval engagement from Guadalcanal to Okinawa. The single most important innovation that enabled rapid destroyer construction was the wholesale replacement of riveting with welding. Traditional ship construction used rivets, metal fasteners that were heated until red hot, inserted through holes in overlapping steel plates, and hammered to form a permanent connection. Riveting was labor-intensive, time-consuming, and required skilled workers. A good riveting crew could install perhaps 200 rivets per day. A Fletcher-class destroyer hull contained over 300,000 connection points. Using rivets alone, hull assembly would take months. Welding, joining metal by melting the edges together and adding filler material, was faster, required fewer workers, and created joints that were actually stronger than riveted connections. But welding required new skills, new equipment, and significant changes to construction procedures. American shipyards embraced welding with an enthusiasm that bordered on revolutionary fervor. Federal Shipbuilding installed electric arc welding equipment throughout its yards. Bath Iron Works trained hundreds of welders. Bethlehem Steel developed specialized welding procedures for different parts of the hull. By 1942, American yards were using welding for 70 to 80% of hull connections, reserving riveting only for specific applications where welding was impractical. The time savings were enormous. Where a riveting crew might need 3 days to connect 2 hull sections, a welding crew could complete the same job in 8 hours. Moreover, welded joints were lighter, eliminating thousands of rivets saved approximately 30 tons of weight, and more watertight. George Patterson, a welder at Bethlehem Steel's San Francisco yard, described the pace of work in a 1944 interview. "We worked in teams. One welder would lay down a bead, another would follow behind checking for flaws, a third would do repairs if needed. We worked around the clock, 3 shifts, 24 hours a day. The hull sections would come to us already cut and shaped. We'd position them on the ways, tack them in place, then weld them permanently. A section that would have taken a week to rivet, we could weld in a day." Japan, by contrast, continued to rely primarily on riveting throughout the war. Japanese yards did use welding, but conservatively, mainly for non-critical connections. This conservatism stemmed partly from concerns about weld quality and partly from institutional resistance to changing proven methods. Japanese naval architects had been trained in riveting. Their quality control systems were built around inspecting rivets. Shifting to welding would require retraining thousands of workers and redesigning inspection procedures. The result was predictable. Japanese destroyer construction proceeded at the deliberate pace of riveted assembly, while American yards welded hulls together at speeds that would have seemed impossible just years earlier. The second major innovation in American destroyer construction was extensive prefabrication, building major ship sections in workshops, then moving them to the construction way for final assembly. Traditional shipbuilding constructed vessels piece by piece on the ways. Workers would build the keel, then add frames, then attach plates, then install bulkheads, then add decks, a sequential process where each step waited for the previous step to complete. The ship remained in one location throughout construction, and workers came to the ship. American yards revolutionized this process by borrowing techniques from automobile manufacturing. Major sections, bow assemblies, stern sections, midship modules complete with machinery were built in workshops away from the construction ways. Workers in workshops had better conditions, shelter from weather, better lighting, proximity to tools and equipment. They could work on components at comfortable heights, not climbing into awkward positions inside a growing ship hull. When sections were complete, massive cranes lifted them, sometimes weighing 50 tons or more, and lowered them onto the ways where they were welded together. A Fletcher-class destroyer might be assembled from 30 to 40 major prefabricated sections, each built simultaneously in different workshops. Bath Iron Works in Maine perfected this approach. The yard divided destroyer construction into modules: forward hull, after hull, midship section, superstructure, deck houses. Each module was built complete with piping, electrical wiring, and equipment already installed. When modules reached the ways, they were essentially plugged together, aligned, welded at the seams, and final connections made between systems. William Haggett, a production supervisor at Bath Iron Works, described the process in his memoirs. "We built destroyers like connecting building blocks. The engine room module would arrive at the ways with engines, boilers, pumps, and piping already installed and tested. We'd lower it into position, weld it to the adjacent modules, connect the piping and electrical systems, and that entire section was complete. What used to take months of work inside a cramped hall now took weeks in spacious workshops." This modular approach had another crucial advantage: parallel construction. Instead of building a ship sequentially, keel, then frames, then plates, then equipment, everything happened simultaneously. While one team assembled hull sections on the ways, other teams were building the next ship's modules in workshops. The moment one ship launched, the next ship's prefabricated sections were ready to be assembled. The rapid expansion of destroyer production required not just new construction methods, but also training thousands of workers who had never built ships before. When war began, American shipyards employed approximately 75,000 workers. By 1943, that number had grown to over 700,000. Most of these new workers came from backgrounds having nothing to do with shipbuilding: farmers, retail clerks, housewives, high school students. They needed to learn welding, pipe fitting, electrical work, rigging, and dozens of other specialized skills. Shipyards established training programs that could take someone with no experience and turn them into a productive worker in weeks. Federal Shipbuilding created a welding school that graduated 200 students per week. Bath Iron Works hired experienced shipbuilders as instructors who taught classes in blueprint reading, ship construction, and safety procedures. The workforce was also increasingly diverse. Women entered shipyard work in large numbers, performing welding, fitting, electrical work, and other jobs previously reserved for men. African Americans found employment in shipyards at higher rates than in most industries. The urgent need for workers broke down some, though not all, traditional barriers. Dorothy Martin, who started working as a welder at Todd Shipyards in Seattle in 1942, recalled her experience. "I had been a school teacher. I had never welded anything in my life. They gave me 2 weeks of training, how to strike an arc, how to maintain the correct distance, how to move the electrodes smoothly. Then they put me on a destroyer hull. I was terrified I'd mess up. But the supervisors were patient, and experienced welders helped. Within a month, I was welding structural joints. Within 3 months, I was training new welders myself." This rapid training was possible because American construction methods had been simplified and standardized. Workers didn't need to understand the theory of naval architecture. They needed to know how to perform specific tasks to exact specifications. The standardization of the Fletcher-class meant that skills learned on one ship transferred directly to the next ship. Japan's shipbuilding workforce, by contrast, remained relatively small and relied heavily on experienced craftsmen whose skills had been developed over years or decades. Japanese yards could not rapidly expand their workforce because their construction methods required expertise that couldn't be taught quickly. This limitation, the inability to scale up the workforce, directly constrained Japan's ability to replace destroyed warships. As American shipyards refined their techniques, construction times plummeted. The average time from keel laying to launching dropped from 9 months in early 1942 to 6 months by 1943. Some yards achieved even more dramatic speeds. Federal Shipbuilding and Drydock Company in Kearney, New Jersey, became legendary for rapid construction. In May 1943, the yard laid the keel of USS Cogswell, DD 651. Just 120 days later, on September 9th, the ship was launched. After fitting out and trials, Cogswell was commissioned on December 17, 1943. Total time from keel to commission, 195 days, barely over 6 months. This was not a one-time achievement. Federal Shipbuilding maintained similar speeds across multiple destroyers. Between 1942 and 1944, the yard completed 24 Fletcher-class destroyers at an average construction time of 174 days from keel laying to commission. The records were closely watched throughout the shipbuilding industry. Competition developed between yards. Bath Iron Works, Todd Shipyards, and Bethlehem Steel all pushed to reduce construction times. Each improvement, a new prefabrication technique, a better welding procedure, more efficient scheduling, was studied and adopted by other yards. Captain Albert Mumma, stationed at Federal Shipbuilding as a Navy inspector, documented the intensity in a series of letters home. The yard operates 24 hours per day. Night shift is as active as day shift. Welders work under floodlights. Cranes move constantly. The noise never stops. There is a sense of urgency. Everyone understands that every day saved in construction might mean a ship arrives in combat in time to make a difference. Meanwhile, Japanese shipyards continued building destroyers at their pre-war pace. The Akizuki-class destroyers, Japan's closest equivalent to the Fletcher-class, required an average of 24 months from keel laying to commission. Japanese yards were not slower because of incompetence or lack of effort. They were slower because their construction methods were fundamentally different. Japanese destroyer construction emphasized individual craftsmanship and quality. Each ship was built carefully, with attention to detail and pride in workmanship. Rivets were installed perfectly, fittings were aligned precisely, paint was applied smoothly. These were beautiful ships, built to high standards by skilled workers who took pride in their craft. But beautiful ships built slowly were losing to good enough ships built quickly. The crucial question was whether destroyers built in 6 months could perform in combat as well as ships built more slowly. If American destroyers were fragile, poorly constructed, or unreliable, their rapid production would be meaningless. Combat provided the answer. Fletcher-class destroyers proved to be exceptionally capable warships. They fought in every major Pacific naval engagement: Guadalcanal, Philippine Sea, Leyte Gulf, Okinawa. They absorbed tremendous punishment and continued fighting. They sailed thousands of miles, operated in extreme weather, and maintained high operational readiness. USS Nicholas, the destroyer whose rapid construction opened this account, served throughout the Pacific War. The ship participated in the naval battle of Guadalcanal, where she engaged Japanese destroyers at point-blank range in chaotic night combat. Nicholas was hit multiple times, but remained operational. She continued to fight through campaigns in the Solomon Islands, the Philippines, and Okinawa. Commander William Brown, who commanded Nicholas from 1943 to 1944, reflected on the ship's construction in his war memoir. "I never had reason to doubt the ship's construction quality. We took hits. We operated at flank speed for extended periods. We rode out typhoons. The ship performed flawlessly. Knowing she had been built in just over 5 months, I wouldn't have believed it possible before the war. But the proof was in combat. She was as tough and reliable as any ship I served on." Other Fletcher-class destroyers demonstrated similar resilience. USS Harriman fought at the Battle off Samar, engaging Japanese battleships and cruisers to protect American escort carriers. Harriman took over 40 hits from large-caliber shells, but survived. USS Johnston fought in the same battle and was sunk only after absorbing catastrophic damage that would have destroyed any destroyer. The combat record proved that American mass production methods did not compromise essential quality. The ships were robustly constructed, their systems were reliable, and their performance equaled or exceeded pre-war destroyers that had taken twice as long to build.
The strategic importance of rapid destroyer construction became clear when comparing American and Japanese replacement rates. Japan entered the war with approximately 115 modern destroyers. During the war, Japan lost 134 destroyers to all causes: combat, accidents, and submarines. Japanese shipyards completed 32 destroyers during the war years. The net result: Japan's destroyer force shrank from 115 to 13 by August 1945. The United States entered the war with 171 destroyers. American losses totaled 71 destroyers. American yards built 349 destroyers during the war, including 175 Fletcher-class. The net result: America's destroyer force grew from 171 to 449 by war's end. These numbers reveal the strategic arithmetic of naval warfare. Japan could not replace losses. Every destroyer sunk was a permanent loss to Japanese naval strength. By 1944, Japanese destroyer flotillas operated at half strength. By 1945, destroyer shortage critically constrained Japanese naval operations. America not only replaced losses, but expanded its destroyer force to meet growing operational demands. By 1945, the Pacific Fleet had sufficient destroyers to screen multiple carrier task forces simultaneously, to escort convoys, to conduct independent operations, and to support amphibious landings, all while maintaining reserves for rotation and repair. Admiral Osamu Nagano, chief of the Imperial Japanese Naval General Staff, recognized this disparity. In a January 1944 memo to the War Ministry, Nagano wrote, "The Americans produce destroyers faster than we can sink them. Their shipyards complete vessels in months. Ours require years. This industrial disparity is decisive. We cannot win a war of attrition against an enemy who replaces losses at 4 times our rate. The story of American destroyer production offers insights that extend beyond warship construction. First, the value of standardization. By building 175 identical ships, American yards achieved efficiencies impossible with custom designs. Workers learned specific tasks and repeated them hundreds of times, becoming extraordinarily proficient. Suppliers manufactured standardized components in large batches, reducing costs and delivery times. Logistics simplified. Every Fletcher-class destroyer used the same spare parts, the same ammunition, the same procedures. Second, the power of process innovation. American yards didn't simply work harder, they worked differently. Welding replaced riveting. Prefabrication replaced sequential construction. Modular assembly replaced piece-by-piece building. These innovations required upfront investment and risk-taking, but they paid enormous dividends in construction speed. Third, the importance of workforce scalability. American construction methods could be performed by workers with relatively brief training. This allowed rapid expansion of the workforce when war demands required it. Japanese methods, dependent on craftsmen with years of experience, could not scale similarly. Finally, the concept of good enough. Fletcher-class destroyers were not individually optimized masterpieces. They were good enough in every important respect. Tough enough to absorb damage, fast enough to perform their missions, armed adequately for their roles. By accepting good enough rather than pursuing perfection, American yards achieved production volumes that decisively affected the war's outcome. When World War II ended, destroyer production ceased almost immediately. Shipyards that had built destroyers in months suddenly had no orders. Workers who had welded holes were laid off. The massive industrial mobilization that had produced 349 destroyers in 4 years evaporated within months. Many Fletcher-class destroyers were decommissioned and placed in reserve. Others served on into the Cold War, receiving upgrades and modernization. Some were transferred to Allied navies and served for decades. The last Fletcher-class destroyer in U.S. Navy service, USS John Rodgers, was decommissioned in 1975, more than 30 years after being built in 6 months. Several Fletcher-class destroyers survive today as museum ships. USS Cassin Young in Boston, USS Kidd in Baton Rouge, and USS The Sullivans in Buffalo preserve these ships for future generations. Visitors can walk their decks, enter their cramped compartments, and imagine the men who fought from these vessels across the Pacific. The construction techniques pioneered during destroyer production influenced post-war shipbuilding. Welding became standard. Prefabrication and modular construction spread throughout the maritime industry. The lessons learned building destroyers in 6 months informed construction of everything from cargo ships to oil tankers to modern warships. The rapid pace of destroyer construction came at a cost that is often overlooked: industrial accidents. Shipyard work was dangerous. Workers climbed scaffolding, operated heavy equipment, worked with molten metal, and labored in confined spaces. The pressure to build ships quickly sometimes led to shortcuts in safety procedures. Accidents were common. Federal shipbuilding recorded 47 fatal accidents and over 2,000 serious injuries during the war years. Bath Iron Works had similar numbers. Nationwide, shipyard accidents killed over 3,000 workers and injured tens of thousands more. Rose Garcia, who worked at Todd Shipyards in Seattle, witnessed a fatal accident in December 1943. Her diary entry captures the human cost. A crane operator lost control of a load.
a 10-ton hull section. It swung loose and struck a scaffold where 3 welders were working. All 3 fell 30 feet to the deck. 2 died at the scene. The 3rd died in the hospital that night. Work stopped for an hour. Then we went back. The supervisor said we couldn't let the accident slow production. The boys fighting in the Pacific needed ships. So we welded and tried not to think about the 3 empty places on the crew. These deaths were not officially combat casualties, but they were war deaths nonetheless. Workers killed building the weapons that others would use in battle. Japanese naval officers were acutely aware of American destroyer production rates. Intelligence reports documented American shipyard capacity. Japanese observers in neutral countries tracked ship launchings. By 1943, Japanese naval planners understood that they were losing the production race catastrophically. Vice Admiral Shigeyoshi Inoue, in a brutally honest assessment written in late 1943, analyzed the strategic implications. American destroyer production exceeds our most pessimistic estimates. They launch destroyers at rates we cannot match or counter. Our destroyers, built carefully over 2 years, face American destroyers built rapidly in 6 months, and the American ships fight just as effectively. This is a war of industrial production, and we are decisively outmatched. Some Japanese naval architects visited American shipyards before the war and were familiar with American industrial capacity. They had warned that war with the United States would become a contest of production, a contest Japan could not win. These warnings were ignored or dismissed by military leadership committed to expansion. By 1944, the warnings had proven prophetic. Japan's destroyer force was being ground down by attrition it could not replace. American destroyer forces grew stronger each month. The strategic balance in the Pacific shifted inexorably toward the United States, driven significantly by the industrial power that could build a destroyer in 6 months. Between 1942 and 1945, American shipyards built 349 destroyers. Of these, 175 were Fletcher-class, built quickly, built in massive numbers, and built well enough to serve effectively in the most demanding naval combat of World War II. These ships escorted convoys across submarine-infested waters. They screened carriers as American naval aviation destroyed Japanese air power. They fought in surface actions from Guadalcanal to Leyte Gulf. They bombarded enemy shores from Tarawa to Okinawa. They rescued downed pilots, evacuated wounded, and served in every imaginable destroyer role. And they were built in 6 months, 1/4 the time Japan required to build comparable ships. This disparity, rapid American construction versus slow Japanese production, exemplified the broader industrial competition that underlay the Pacific War. Japan built beautiful ships, slowly, using traditional methods with skilled craftsmen. America built good enough ships quickly, using industrial methods with hastily trained workers. In a long war of attrition, the American approach proved decisive. Admiral Ernest King, Chief of Naval Operations during World War II, summarized the lesson in his 1952 memoir. We did not win the Pacific War primarily through superior strategy or superior tactics, though both mattered. We won through superior production. We built ships faster than Japan could sink them. We built destroyers in 6 months that took Japan 2 years. That advantage, the ability to rapidly replace losses and expand forces, was ultimately insurmountable. Japan could not compete industrially, and in a modern naval war, industrial competition is the foundation on which everything else rests. The Fletcher-class destroyers, built on assembly lines using techniques borrowed from automobile factories, symbolized American industrial power applied to warfare. They were not elegant or beautiful. They were functional, effective, and above all, numerous. And in the brutal arithmetic of modern war, numerous was enough.